Hello, pre-calculus students. We continue our lessons, our examples with proofs of trigonometric functions, and we're going to learn a new strategy in this video, and this is called working both sides. So in most proofs that we've done, we usually started either on the left side and we try to get it equal to the right side, or we started on the right side and try to get equal to the left side. And now this proof, I'm going to show you how you can do some work on the left side by itself, do some work on the right side, and then show that those two are really equal to each other. Okay? And so this is the proof that we have. We're asked to solve or prove that 1 plus sine over cosine is really equal to 1 over secant minus tangent. So I'm going to start step 1 here with the left hand side. 1 plus sine of x over cosine of x. Okay. And this is given. Now, next step that I'm going to do is also a pretty nice strategy to employ sometimes. We have an addition problem on top, and it's got one denominator, so we can actually split this into two separate fractions. 1 over cosine plus sine over cosine. Okay. And so we're going to split into two fractions with same denominator. And this is okay if the addition is in the numerator. Be very careful, if you have an addition problem in the denominator, you cannot split it in the same manner that we're doing here. Okay, so let me give you kind of a side example. This is really like saying 2 plus 5 over 6, which we know is 7 over 6, is really equal to 2 over 6 plus 5 over 6. Okay, so be very careful here. It only works if the addition or the plus sign is in the numerator. It will not work if it occurs in the denominator. So just be careful about splitting these fractions and the way in which we do it. Okay. And the reason that I wanted to split these fractions is that I have a secant here in the right hand side and a tangent here in the right hand side. Okay. So by splitting this, 1 over cosine is really secant, and sine over cosine is really tangent. So that gets me a little bit closer to what I wanted to prove. I'm not quite there yet. I have a secant and a tangent here, but it's not in the same way. It's not written in the same way as secant, or sorry, 1 over secant minus tangent. Okay. So I'm going to pause right here. I'm going to label this again. This is the left hand side that I've been working on. And now what I'm going to do is start working on the right hand side. Okay. So I'm going to start. So this is perfectly okay. I've taken the left hand side and I've worked it up to this point, and now I'm going to work on the right hand side, and I'm going to try and show that the right hand side is also equal to this statement. Okay. So for the right hand side, I have 1 over secant of x minus tangent of x. Okay. And what I'm going to do is multiply this by secant of x plus, let me make this clearer here so it's easier to see. I'm going to multiply this by secant of x plus tangent of x over secant of x plus tangent of x. So what I've effectively done here is multiply this by 1. Okay, we've seen this strategy before, and it's perfectly fine to multiply like this, even if it's not the same denominator, because this expression that I've multiplied by is effectively 1. Okay, so my reason here is really multiplying by 1. And things are going to get a little bit more complicated before it gets more clear. But in many ways, that's the beauty of proofs in mathematics. So we're going to multiply the numerator here, and that gives me secant of x plus tangent of x divided by secant of x minus tangent of x. Put that in brackets, and brackets here don't mean anything different than parentheses, just makes things a little bit easier for us to see. Okay, and this is multiplying fractions. So continuing with the proof now, I got it up to this point and it's pretty complicated, and I'm actually going to make it even more complicated by foiling or distributing the denominator here. So my numerator stays exactly the same. I have secant of x plus tangent of x. And in my denominator, I am going to use the distributive property, otherwise known in this case as FOIL. So the first terms gives me secant squared of x. The outer terms gives me secant times tangent. The inner term gives me negative secant times tangent. Let me erase this line right here. Okay. And the last terms here give me negative tangent squared of x. And this is, again, FOIL, or the distributive property. I'll write this right here. Okay. So in my next step, you can see here that secant x plus tangent, and I have minus, so I have a plus secant x tangent, and I have a minus secant x tangent, so those two are going to cancel, and this is really just simplifying. So on the top I still have the same thing, secant of x plus tangent of x over secant squared of x minus tangent squared of x. Okay. And this is simplifying. Now look at the denominator. You have secant squared minus tangent squared, and I just want to go back a little bit to the Pythagorean identities. Okay, so many of these proofs eventually reduce to these three identities, and I want to point your attention to the second identity right here, which is 1 plus tangent squared equals secant squared. So what I could do is subtract tangent squared from both sides, and this gives me secant squared minus tangent squared is equal to 1, which, if you notice, this part is the same as what I have right here in the denominator. So instead of this expression, I can just replace it with 1. Okay, so I have secant of x plus tangent of x divided by 1. And my reason here is the second Pythagorean identity, Pythagorean identity number 2. And then, of course, this all reduces down to secant of x plus tangent of x. Okay? And this is the right-hand side. But if you notice, back in our proof just a few steps, we also here we got the left-hand side to be the exact same thing. So we show that the left-hand side is really secant x plus tangent of x, and now we've shown that the right-hand side is also secant x plus tangent of x. So we can say here that the left-hand side from step 9, or sorry, from step 3, is really equal to the right-hand side from step 9 in our proof here. And left-hand side equals right-hand side, so our proof is done. And if you notice, we've really just worked on the left till step 3, worked on the right to the end.